Hello, this is Sayed from iEngineering. Today I'm gonna show you how to do pole profiling or ASPL3 design in NEARA software. This is a NEARA interface. This is the home page for NEARA. You can see here the start button from where you can start your own project, like from preset files or from models. Here you can see the recent files where you have done the recent projects on NEARA. So you can do like that. First I will start with the recent design. So this is the design we are gonna do today. This is the 99 May Street at Goulburn NSW design. So we will start with the design. First we will start with the placing poles, then conductors, then adding tension on the conductor, etc. So we can put the poles by adding directly. We can directly put the poles, or we can export data from CSV file, either later data, etc. So today I will show you first how to put the poles. First we have to just click here and we can start putting the poles on the where it is actually located. So I will put some random poles for your example, 1 2 3, like that. Now I will just show you uh, what are the properties in properties panel. Showed you what types of the poles. Here's the general properties of the poles. You can say sinking depth, height above ground, etc. You can see here clearly. The easting northing of the pole you can see clearly. Now I will show you how to add a conductor. So for adding a conductor you have to just click here and just select the poles to add a conductor. Now you can see clearly that conductors are adding. If you want to stop adding conductor, just press skip from your keyboard. So now I will just click on the conductor, and I can see the general properties of the conductor. What is the type of the conductor? It's Gemini 7/1.75 AAC. What is the voltage level of the conductor? You can change the voltage level from here. What is the number of conductors there? What is the creep offset? What is the maximum operating temperature of the conductor? What is the tension on that conductor? You can see, or you can see clearly that conductor is passing or failing. Okay, so I will delete for the while all these things. Now I will add a proper data from CSV format which I made for this project. I will import CSV data from here. So it's saying me, so we have to select where is our file. I will go to file. I will import it. It is imported. I will select combination. So you can see it is imported. Now I will apply it. So you can see all the poles and everything is added here. You can clearly see all the poles are everything is added. Now what I will do, I will just select the poles and I will just give a proper naming and everything. I will select the pole. I will give it what is the strength of the pole, what is the height of the pole. Okay, so that pole is 8 pt 9.5. See, you can see clearly 8 pt 9.5. You can see. So I set all the poles here. Now what I will gonna do, I will add the conductors on the poles. So here you can select the conductors from here. You can see now you can start adding the conductors one by one. You can click on the poles, so it automatically added the conductors. You can see the conductors are adding on the poles. So I will add the conductors towards last pole. So I added all the conductor. If you want to just skip it, so you can out of the command. Now skip it. Now I will select the conductor and I will give the proper, here is the general properties, and I will select the proper conductor which we are using. So this conductor is uh, you can see BEE. You can just type BEE. The conductor is BEE 7/1.4. So I added that conductor. It's a 33 kV line, so I will add that. You can see the number of conductors for HV is 3, and here you can see the bundles, the maximum operating temperature, the tension. I put 9% tension, that is according to the standard only. Now I will just update the attachment height on every pole. You can see that the attachment height on the 86 is 10.2, the attachment height on 85 is 10.2. Every pole the attachment height is different. So on 86 the attachment is fine now, but on 8 on 85 you can see the attachment height is 10.2, so it should be 14.2 because the pole is bigger. So similarly the pole 83 84 also 17-meter pole, so I will add 14.2. So you can see now the other things you look fine. So what I will select, I will just select the construction type. You can see here the construction is CEMO 33 kV line pin star delta, that is according to this standard CEMO 7010543 wire 3 kV, that is fine. So it's using correct standard construction for that pole. You can see here clearly in profile, you can see here clearly in profiling. Now I will add another conductor for LV. So I will again add conductors for LV till last pole. So I will again press escape. Now I will select the conductors and I will change it to Mercury. Mercury. So Mercury is came here. Now I will change it to 415 and I will change it to 4. Okay, now what I will do, I will change everywhere the attachment height. So the attachment height is too less here, you can increase up to here 8.5. You can see according to your requirements. Here I will increase up to 10.5. You can see clearly here also 10.5. Here you can see what we put here, what we put, we can put same here also. Yeah, I will put 7.87. So it will, okay, 7.87. Oh, sorry, 7.87. Here also I will put 7.87. 7.87. It should be according to standard only. 7.87. Again I will put the tension on that conductor as 9% according to standards. So in this way we can do pole profiling in NEARA. So now I will check each and every pole, is it pole is passing or failing. So for checking that pole you have to go to structure. You can see this pole is passing, failing, sorry, this pole is failing. Why? Because there is no conductor connected on other side of that pole. So we will go next. Now you can see this pole is passing. See, in every condition is passing. Uplift passing, snow and ice passing, everyday is passing, maximum. Basically, we will see both these two, everyday and maximum demand for ASPL3 design. So to check the pole whether is passing, how it's calculated. The total tip load limits it is. You can see the D rating for wood material is for snow and ice is 0.28. Okay. Similarly, for moment limit, D rating is 0.285. You can see. Okay. For every day, if I will check, the D rating is 0.285 for wood pole. So what is our total tip load is coming 0.9, and what is our maximum limit is 11.11. That's why this pole is passing. Similarly, with the maximum moment, it's coming 1.26 and our limit is 161. So that's why it is passing. Same with the maximum wind conditions. So you can see here. Now if you want to check whether our conductor meets the ground clearance, you have to go to this tool and just check whether your clear conductor is matching the ground, clearing the ground clearance. Okay, if you just put it, you can see on the right corner the maximum span where your cursor is 8.79 currently. If you want a minimum span, you can just go to that pole from C85 to 84, that is 8.6. The requirement is 6 meter. So here you can see the 6 meter is not meeting between 883 and 882. If I go to 883 and 882, where is that? I'll just press escape. I'll press escape. See here, it is not meeting. 5.77. Okay, so that's it from my side. Thank you so much for watching my video.